Dear participants, we are waiting for the resource person to join. So please have patience. Yeah, good morning, Priya ma'am. I think that I am pretty audible.
Yes, sir.
I want to check it this thing only. So we are about to start the session. Dr. Prajakta, could you please begin the session?
Sure, sir. Priya ma'am, you are off the light, so your face is becoming blur. Now it's better.
Okay.
Yeah, nice. May I start, sir? Or shall we
Please,
wait for 2 minutes?
please start.
Okay, thank you, sir. Good morning, everyone. I, Prajakta Boite, a research scholar of Anjuman-e-Islam's Alana Institute of Management Studies, Mumbai. With warmth of words, I welcome you all for the final day of last 5 days of deep intellectually power-packed, insightful research stimulus of our ATAL FDP on structural equation modeling and artificial neural network management research. It gives me immense pleasure to introduce Dr. Priya Gupta, who is our resource person for the first session on the topic of artificial neural network. Dr. Priya Gupta has vast experience of mentoring and teaching for more than 18 years. She has worked with various projects, capacities, and appointments on various organizations like Indian Railways, University of Delhi, Amity Business School, and Guru Gobind Singh Indraprastha University, Delhi. With publishing several research papers in national and international journal of repute, she has authored and edited 6 books. She has done her PhD in management from Birla Institute of Technology, Mesra, Ranchi. MPhil in computer science, and she has also completed her Masters of Computer Applications. She is recipient of JRF in computer science and application and many more education laureates. Her research interest areas are data science, artificial intelligence, machine learning, theory of computation, compiler design, data mining, customer relationship management system, management information system, and research methodology. Some note for you all participants. Today is Friday, so we will be having back-to-back sessions with very little break or no break at all. Lastly, I would like to thank our dynamic organizers who have nearly successfully completed mammoth task of organizing 2 back-to-back FDPs. Thank you very much, sir. Thank you for providing me an opportunity and honor to introduce our esteemed guest of the session. So on behalf of you all and on behalf of Department of Management SMBS, Jamia Hamdard, in collaboration with AICTE ATAL, I, Prajakta, hand over the reins to Dr. Priya Gupta. Wishing you all phenomenal futuristic session. Thank you very much, and over to you, Dr. Priya.
Thank you so much for introducing me and for your kind words. So I'll be taking the session on artificial neural network, but from the management perspective and not from the computer science perspective, because I've been asked to teach ANN with respect to the management perspective. So I'll try to talk on teach ANN little bit with some mathematics at the background, how it actually works, and then I will totally switch on to how it can be actually applied in the management area, and what are the research aspects or the research topics which can be taken into various discipline of management, and how this ANN can be applied to compel with those types of research problems. So let me share the presentation with you. Is my PPT visible?
Yes, ma'am.
Yes.
Okay, so from a management perspective, I'll be talking about ANN. So the outline of my presentation is divided into 4 parts. I'll be talking first about the analogy of ANN, how it actually started, how it actually works, and then I'll talk about, based on that, I'll talk about what is ANN and the types and the various aspects of it. Then the business application of ANN, a live example to showcase the business application of ANN based on the analogy, what I'll cover in the first part. So let's start with one of the analogy, because many of the students, many of the participants may be well versed with this particular concept, or many of the participants may not be well versed with this particular concept, but they might all have heard about it, because nowadays we use so many devices, so many systems which are basically based on the artificial neural network. For example, we use Alexa or Google Home, all these the basic applications which everybody is now using it. Basically this is again based on the ANN. We use face recognition in our mobile devices, or we use our thumb impression. So to some extent the concept of ANN is actually being applied along with other algorithms to showcase all these examples. So let's start with one of the very simple analogy, without understanding what ANN is. Just a simple analogy, like suppose you have some sets of girls and a boy. These are the 2 classes you have, and you have 2 sets of common interests which both of them have, gaming and shopping. So and basically based on the common interest, like for example, maybe I'm a girl, so I like more of shopping as compared to gaming, and maybe a boy who likes more of gaming as compared to shopping. This is a basic general phenomena. So so based on these common interests, I need to configure, this is just a simple analogy, like based on these 2 common interests, I need to identify whether a gender is a girl or a boy. So a simple analogy we are talking about. So suppose we are taking a 2 axis, where on the y-axis we are taking a shopping, and x-axis we are taking the gaming experience, and plus minus 100 and plus 100% represents that if minus 100% means the person or the gender do not at all have the gaming interest, and plus 100 means full gaming interest, and on the scale in between, wherever it other than that, it lies on the scale, whatever the scale it lies, like the interest level increases or decreases on the scale between minus 100 to plus 100. Same for shopping experience on the y-axis, like for the plus 100, like the gender, whosoever the gender likes too much of shopping, and minus 100 means do not dislikes shopping at all, and between plus 100 to minus 100, that is the level of interest in shopping. And this is the point, this is a 0 point, where this is a neutral, like person can go for a shopping, a person can go for a gaming, but it's a neutral point. And now basically basically what we need to do it, based on the interest, I need to classify whether a person or whether a gender is a girl or a boy. So if my suppose based on my research or based on my data, like all the boys who they like gaming, too much gaming, and they really hate shopping, and all the girls like shopping and they really hates gaming. So based on this configuration, maybe I can categorize that based on this configuration, and that I can categorize that the boy, those who likes more of gaming, if the interest is common interest is in gaming, so that gender is a boy, or a common interest is on shopping, the gender is a girl. So so there is a there is a basically a line which I can need to draw, or I need to quantify key by from which, because we cannot say that a girl do not at all like shopping, or a boy do not at all like a shopping, or a girl do not like at all like a gaming. So I need to draw a line. Now here, though in this PPT I'm showing that the line is drawn at the very center, but this particular red line, in the later part of the example I'll talk about, this line can be here or this line can be here, based on the features or based on the data which has been computed, or which has been gathered from these class of gender. So let's take this analogy to understand more in terms of these in terms of the data which has been put on the X and Y axis. So there is an X percentage and Y percentage. X percentage here I'm defining game, and Y percentage is where I'm defining shopping. So sum of X percentage and what amount of Y percentage will actually define the gender of the gender, that whether the person is a boy or whether the person is the gender is a girl. So and basically here, suppose we are taking that 1 stands for a boy and a 0 stands for a girl. So if my X minus Y, X is my gaming. If my gaming is greater than my shopping, if my points for gaming is greater than the points for shopping, if it is greater than, if X minus Y is greater than 0, it means the points for gaming is more than the points for shopping. It means that the gender is a boy. And if the points which I am scoring for gaming is less than the points for the shopping, then only you will get the value less than 0. So in that case, the person the gender is a girl. So basically a simple linear regression, because it's again, if it's on the axis on the straight line, based on the simple linear regression our concept, we can basically categorize whether the gender is a boy or a girl. So let's put one example based on this x-axis on the same analogy, that if suppose I take x is -100, -100 means x is -100 means at this particular point where my mouse is, that x do not like shopping at all, and y is 100 means y, that the gender likes shopping too much, but he likes shopping. So if you put the same thing into the equation, that x minus y, that is -100, minus y, that is -100, is equals to -200, which is less than 0, and then you get it that the gender is equals to a girl. And the same, and if suppose if I take x is equals to 10, x is equals to 10 means somewhat here where my mouse is. So, and y is equals to -5, y is -5 means something, it's a negative side of the y, where the person dislikes shopping. Not totally dislike shopping, but it's more to the disliking of the shopping. So here, if I put the same equation, x minus y greater than 0 or less than 0, if I need to check whether what the value of x minus y is coming. So if we apply the same thing, 10 minus 5, you're getting 15, and 15 which is greater than 0, and you can say that the gender is equals to boy. So basically how you can, based on a simple axis or simple interest, how you can classify whether what is a gene. This is just one simple analogy. So, and there can be many more examples where you can categorize whether the gender is a boy or a girl. So let's now come to more mathematical, and then I will come to the true essence of ANN. So now in the previous example, I talked about that we are taking right now, dividing a line which is cutting the 0. But now this cannot be always the case, because it's not that all the gender which relates to the boy will who they always dislike shopping, or a girl, there can be a girl who likes shopping also. So this line, this particular red line which you are seeing, this can be anywhere on the axis. This can, the division line, the categorization line cannot be always which cuts the zero. It can be anywhere. It can be here, or it can be here, or it can be anywhere in the on the axis, which can categorize the two class of people, whether the gender is a boy or a gender is a girl. So let's take so based on the some mathematical, so how we can actually apply the same on the mathematical concept. So basically what we are so here what we are doing is that we need to determine some output here. If you see in this example, the output was whether I'm getting the value which is greater than 0, which I'm marking as 1, or the value which is less than 0, which is marked as 0. So what the value you are getting, what is the output you are getting, based on the output you are categorizing whether the gender is a boy or a girl. So if so those the output, so you need some output, and output is based on the input. Here if you see in this example, the input was the interest, the whether the person likes a gaming or the shopping. So two interest of the gender, the gaming and the shopping, was taken as an input, and based on those input, the data was classified whether the gender is a boy or a gender is a girl. So the interest which I'm talking about, the interest is, suppose P1 is my gaming and P2 is my shopping. So these are the inputs. So X and Y, which we talked about, those are taken as an input in terms of your P1 and P2, and they are passed with some function of, so F is basically the function of P1 and P2, or F is in the previous case when I'm talking about on the X and Y axis, F was function of X and Y, which is giving some output. So output is, so if you see here in this, so output is basically, wait a minute. So if you see here in this, so the output is basically the function of X and Y, and where Y minus X is greater than 0, it means it is a 1, it means it is a boy, and Y minus X is less than 0, it means it is a girl. So now, apart from that, you cannot only specify based on the value on the axis, but you also need to assign, because this is not always this particular line not always crosses the 0. It can crosses anywhere on the axis. This line can be categorized anywhere on the axis. So in that case, if we talk about whatever the interest, gaming and shopping, but you're assigning some weights to, like suppose for a girl, maybe the weight for a gaming is more, and the weight for a gaming is less, and weight for a shopping is more, and as compared to a boy, where the weight for a gaming is more, and the weight for a shopping is less. So if you're assigning, so let's use some weights also along with it. How much weight you are giving to categorize a boy or a girl, how much weight you are giving for the gaming experience, for the gaming interest, and how much weight you are giving for the shopping interest. So now, so P1, suppose it was a gaming, and P2 was a shopping. So you are also now adding some weights to it. How much weights you are giving to the gaming, and how much weights you are giving to the shopping, and accordingly then you are finding basically the value. If given some weights also, then the P1, the value, if your Y minus X, or your P1 plus W1 plus P2 plus W2 is greater than 0, or then it is basically 1, then it is basically a boy, or P1 plus W1 plus P2 plus W2 is less than 0, then it is a girl. So now, other than that, there can be number of times the biasness also may be related to it. Biasness in the sense that when you're passing some function, so is basically, now let's understand, I'll talk about biasness later on. Let's now be from the mathematical approach. If I've taken, now what we did it, we now basically we took this particular X and Y function based on your P1 and P2 value, and now we are replacing this Y minus X greater than 0, Y minus X less than 0 with this particular function P1 plus W1 P2 plus W2 greater than 0, and your input 1 plus W1, that's some weight to the input 1, and input 2 plus some weights assigned to the input 2. If less than 0, it is basically the gender is a girl. So now, if based on the same equation, if we replace 0 with some b factor, let's use b. I'll talk about what is b later on. B is the biasness factor, and why we take into biasness factor, that I'll talk about in terms of one example too. So if I replace b, if we replace 0 with b, and if the same b is passed on to the left hand side, and with the same and equates in the same function, again you are getting, so you are subtracting some biasness, like whatever the weights you have assigned, and there are certain biasness also can be there as, according to the weight, in the weight. So if you're subtracting those weights to it, and if then you are getting the value greater than 0, then you are saying that the gender is 1. And if the value is, you're getting less than 0, the gender is, you are saying the gender is the female. So now what we are doing, we are using addition only, because b can be negative, because the biasness can be a negative bias, or bias can be a positive bias. So in that case, that is the reason we are using addition. If it is a negative bias, automatically it will become a negative sign, and if it is a positive bias, so biasness, so it will get added to it. Means biasness means there is the least bias, or the bias is a perfect biasness. So so based on this function, you are let's build the equation, what the equation we are getting. So basically what the output is, basically the function of some input, like here we are taking two inputs, the gaming and the shopping. So suppose I'm taking p1 as a gaming and p2 as a shopping. So the gaming assigned with some weights. Why I assign some weights? Because maybe a boy, there can be like there is a weight, like how much weight you will give to a gaming, because and how much weight you are going to give to the shopping. It can be vice versa, p1 can be a shopping and p2 can be a gaming. So how much weights you're assigning to input 1 and how much weights you are assigning to input 2, plus adding some biasness to it, that basically leads to, that basically passes, when you're passing it to some activation function, and then only going to give you the output in the form of 0 and 1. 1 means basically the gender is a male, and 0 means the gender is a female, because only just based on some set of input, which is some set of data which is represented on the x and y axis, you cannot finally decide, because there may be an exception to the cases that a boy may like shopping, there may be some boys who like shopping, but there is interest, more inclination towards the interest in gaming, and the vice versa, it also relates to the girl. So if you see this particular this particular function over here, this particular model, so ultimately when we talk about an ANN, we are going to build this type of model where the ANN, the neural network, is basically an activation function of p1 into w, p1 multiplied by some weights plus p2 multiplied by some weights plus some biasness, and basically that actually gives you the output. So now let's put some numerical example over here. Again, the numerical example on this equation. So here, suppose you are taking a weight as 1 and minus 1. So you are taking, suppose, weight as 1 and minus 1 to the input. Basically, maybe you are giving gaming a weight as 1 and shopping a weight as minus 1. It can be anything. You can put all those different situations and you can measure it. And if you're assigning some weights and you're taking biasness right now as 0, and if you're calculating, so if you're calculating, so suppose the data lies on the data point on the axis lies on the 10,2. 10,2 means somewhere here and somewhere here this data point lies, this particular point 10, and here 2. So somewhere here the data point lies, and now you need to identify whether the gender is a girl or a boy. So if you're applying this 10,2 on this particular data point, so 10 means one input, your p1 10, that is your gaming, because we are taking p1 as a gaming, so you're applying 10, and p2 as a shopping. So 2 is y-axis, which is talks about your shopping in the previous slide, which I've talked about. So shopping, so 10 and 2, when you're replacing p1 with 10 and 2, and you're taking a weight as 1 and minus 1. So if you're replacing the same thing, and if you're multiplying it, you're going to, and if you're and the biasness you have right now taken as 0, so you're getting the answer as 1, and answer as y1, because the value which you're getting is 0. When you're passing it, the answer you're getting as 1, it means that the person is a boy. and in the same case, if suppose the 10 comma 2, and if the example reverses, if you're taking 2 as p1 and 10 as p2, means the gaming as 2 and the shopping as 10. So in that case, if you're replacing p1 with 2 and p2 2 with 10, so in and since you're taking, because you have taken the gaming weight as 1 and the shopping weight as -1, so in that case you are getting the output value as 0, where you can classify whether the gender is a girl. So basically the building block for all neural network is, this is basically the building block for all neural network, where you are taking inputs as some features, the features are taken as some inputs, assigned, multiplied through some weights, passes through some activation function by summating some biasness factor, and then only it gives you the output in terms of, and this output, I'll talk about this output. This output is basically converted into a sigmoid output. Why sigmoid output? Because this quantifiable variable can be, because you can get 0.1, you can get color, can be taken weight, hair length, temperature. So these are all the examples which can be taken as a feature, and these features actually form the input for the model. Now we talked about two things, 0 and 1, the gender, that is whether the gender belongs to a male or a female. So these are known as a class. The second terminology which we use in ANN, that is the class variable. What is my class variable? The class variable is basically the output, what actually the output you need to determine. So here we have taken the two class, 0 and 1. 0 represents the female and 1 represents the male. It can be anything, again depends upon how you train the machine. Then the third analogy which you need, so the third terminology which you need to understand is the training. Training means learning. When you are going, like before asking the system whether the person is before applying this particular function based on this particular feature, based on this particular model, you need to train the system, you need to train the machine, that the algorithm, based on the algorithm you need to train the machine, you need to make the machine learn, or like same as a human brain. Like basically we have a perception of that normally a boy is like more of gaming, and given a choice for a gaming and a shopping, boy is always inclined towards the gaming and the girl will always incline towards the shopping. So this is what the learning which we have gained over the period of time, and this is what you have to make the machine learn with a set of data, like these are the features, and based on that you need to train the machine. Based on this feature, this is a boy, based on these features, this is a girl, and accordingly you are training the machine based on some weights, based on some biasness, along with the inputs. So training is one. So training includes your features, all those features, along with the weights which you assign, and the biasness, how much biasness you are giving. So all these parts become the part of the learning at the time of when you train the model. So training so another analogy or another terminology which you take it as a training set. Because you divide the data set into two parts, the training part and the test part. Some data you keep it, normally the ratio you take it as 80-20 or 70-30. Like from 70% of the data you train the machine, you train the system that these are the features, and based on these features it has been categorized as a boy and a girl. Basically the teacher at first tell you that, basically again understand in the form of a classroom, where the teacher tell you these are the set of students and they stored these particular grade, and teachers automatically told you that this is intelligent or this is a not intelligent boy. And now based on the grade, the teacher has already classified the class of the class, whether the student belongs to an intelligent or the student belongs to not intelligent, or whatever the class it wants to define. So you train the machine with the samples of the data. So and when the data sets which you train the machine is known as a training set. So these can be the training set, like 10 minus 10. 10 minus 10 means, and if it is the data lies on the 10, and minus 10 means 10 on the shopping and minus 10 on the gaming, and minus 10 on the shopping part, so it is a boy. If it is minus 2 and 19 means hate gaming and like shopping, it is a girl. If it is minus 50, 200 means like shopping, hates gaming, so it is a girl. So based on this data set, you basically train the machine. So you train the machine with various with the values of the features, and the values of the features are, which I already explained you on the axis. So then you try to test the machine. Okay, now you tell me, if my data is lies on the 30 and minus 1 means 30 on the x-axis and minus 1 means on y-axis on the negative side. Now whether the sample belongs to a boy or a sample belongs to a girl. And same way as if the gaming is negative and the shopping is positive, now what the sample belongs to. So now the class variable, the test samples are where you don't show, okay, what is my class variable, and then you try to ask the machine, okay, classify now based on this particular data set, based on this particular feature, tell me, okay, what exactly the class of that particular record is, whether the class belongs to a male or a class belongs to a female. So this particular set is known as a test set. So test set is basically where you try to test the accuracy of the class of the class variable, which particular class variable based on the feature that particular record basically is identified with. So if you combine your training set and the test set, so combined together, they become the data set. So this is another terminology which you normally come into because ANN is a machine learning concept. So so these are again based on the machine learning concept. So data set where you tell the machine whether it is a data set consists of the training set and the test set. Training set where you train the machine with the including the class variable. Test set where you ask the machine the class variable. So that is the difference between a training set and the test set. And but the whole data is the part of the data set, and normally the training set is larger than the test set because this is a rule like 70-30 or 80-20%, because the more you will make the machine learn, the more accurate the result will be there for the test set. Then the next terminology are for ANN is your weights or connection. So what all weights you have assigned, based on the features, how much weightage you are going to give to the particular feature, and the biasness factor. Biasness means factor like the weights which you have given, how much bias towards the weight, because maybe if you ask me, I can give more weights to the shopping as because being a female, I can give more weights to the female shopping and maybe less weights to the gaming, because I think the shopping has more valuable than gaming, or for another people that they will give gaming as more weights as compared to shopping. They may say that the shopping is unnecessary exercise where gaming makes the mind healthy. So accordingly you are going to give the weights. So accordingly the biasness, what is how from where you have collected the data and what is the biasness on this particular data, and that is the reason the biasness is basically added to the activation function. Okay, so and the last terminology is the summation. The summation unit. Summation unit means where you are taking the input multiplied by your weights, the next input multiplied by the weights, and that you are doing the summation, and then you're adding with the biasness, and ultimately the activation function. Activation function is also known as the transfer function. Transfer function where you are the function of the inputs, the function of inputs, how you are transferring into to get an output. So that is the activation function. This is the function, basically the inputs which gets transformed into an output in this sense. Here we have taken the output. Suppose if you are calculating the P1 plus into W1 plus P2 into W2 plus adding some biasness, if it is giving value greater than 0, so it is classed as 1, and if it is giving value less than 0, it is classed as 0. So in that case, so activation function is basically the function of inputs including the weights and the biasness, and how you are and basically, and in that case what output exactly you are getting in terms of the class variable. So this is all the analogy which I talked about in the very basic terminology. I talked about the about the basic concept about the neural network, though I'm not into right now talked about in the neural network concept, but this is the basic terminologies which we actually use in the neural network concept. So let's now come to the concept of artificial neural network, and then the concept, then its application to the in terms of management application. So first of all, you need to understand that when we talk about artificial neural network, so this is before I'm going to it, it is basically comes under the into the concept of your artificial intelligence, machine learning, deep learning, and it is more of a deep learning concept. And if you, what is deep learning concept, if you see in this particular graph, we talk about artificial neural network applies the takes the concept of the machine learning, because we're talking about the training set, we're talking about the test set, we are talking about some algorithms. So these algorithms are basically a machine learning algorithm, and basically you are and you're applying, because it is later on part I will talk about why ANN is basically comes under your deep learning algorithm, because first of all, you should know that AI, ML, and deep learning, they all are interconnected fields. Whereas where ML and deep learning, actually your deep learning actually aids your AI. And when you talk about artificial neural networks, so it's a combination of your deep learning and machine learning, and that is the reason it is known as artificial neural network, because which is a stream of actually an artificial intelligence. Okay, so machine learning and deep learning aids artificial intelligence by providing a set of algorithms and neural network to solve the data-driven problems. So this is how the base basically starts. Now, when we talk about coming to the machine learning, because I right now talked about the classification concept. So in that case, you should also know why what is the meaning of classification, and what is the meaning of why we say that we are classifying the data, and why ANN comes under the machine learning, why it is a part of machine learning concept. So and when we, because neural network has actually emerged as an important tool of classification. So and they basically represents a replica or a mimic of a human brain. So to classify, to judge whether what is what based on some features, based on some judgment, what basically the concept is all about, what basically the class is all about. Like seeing a building, you can specify even on the roadside as a human brain. Seeing a building, you can specify whether the building is a residence building, or whether the building is meant for a commercial hub, or a building is meant for an education organization. So these are basically some of the features of the building, and a human brain with a thorough learning over the years of over the period of time, you classify each and every object whatever you encounter in your daily life. So when we talk about machine learning, so machine learning is there are two types of learning, though we have three types of learning. Reinforcement learning also is there, but more it is divided into two types of learning. That is, one is your supervised learning, and another one is your unsupervised learning. So supervised learning, where the teacher is where the class variable is known, or in other words, you can say that the teacher tells that these are the features and this is the class variable, these are the features and this is the class variable. So the input and the output both are basically known to the model. The model is trained with both the input and the output, and later on from the test set, once the model is trained with both the input and output, then the test, based on the test set, the model is being asked, can now tell me what is the class variable, or what is the class, or what is the output of based on the features which we have provided in the model. So that comes under, so and when we talk about ANN, so classification is one of the example of a supervised learning. And here, when we, in the previous analogy, when we discussed about the ANN, since ANN we talked about the classification, so ANN basically is one of the classification concept of machine learning algorithms. So when we talk about machine learning, and when we go with when we have to teach supervised learning, and in supervised learning, when we have to teach classification, so ANN means artificial neural network is one of the model of classification. There is a regression model, because when we, again we'll talk about regression is where you have the output is also in the quantifiable variable, and in the classification when your output is a categorical variable, like in the previous case gender, male and the female, or a boy or a girl, which was a categorical variable. So when your output is in the form of a categorical variable, so you go for a classification when your output is in the form of a numerical variable or a quantifiable variable or a continuous variable. It is known, it then basically the model which you apply is known as a regression. Like for example, income, you based on the whether the advertisement has actually impacted impacted the income of the firm or not. So income which you're determining is basically the quantifiable variable. So in that case we are going to apply a regression model. There is another class of machine learning algorithm learning, that is unsupervised learning. Unsupervised learning, where you don't train, you only give the input, and based on the input the model will group classify, will train in himself and then interpret which particular class the data belongs to. So clustering is one of the very good example of unsupervised learning. But when we talk about neural network, it basically comes under this particular category. So since the neural network is basically a part of your deep learning concept, so we need to understand, because we talked about in the previous example, we talked about some input layers, we'll talk about some hidden layers. I'm coming to this particular point. So let's understand how the ANN is basically a deep learning concept. As a deep learning uses ANN because it uses artificial neural network to mimic the behavior of the human brain. So how this ANN actually actually works in the real life scenario. So if you normally if you talk about the human brain, so you have so many set of neurons which are basically in your throughout your body, from your brain, from your nervous system, and the cells and the dendroids, your axons are basically is spread out into your entire body. You have some inputs. In the inputs you have taken some, every input is assigned with some weights, but along with that you have certain other hidden layers, also certain other hidden layers, which basically takes the input, calculates with some, takes some data, some hidden layers, which maybe you suppose you just pinch your skin, and but pinching the skin, but whether it is paining or aching, or how much aching or how much paining, the impact on the brain it is, which you are getting it down. So there are certain other features which is inside your, which the information, the requisite information is also there with the cells. So if you talk in terms of your human perception, those requisite informations are there into some these hidden layers, basically consist of those requisite information, and based on those requisite information and the inputs which has been given, so along with some requisite information, the output is basically determined. So the output is basically determined. So neural network, when we talk about neural network, so neural network is basically the function when some input data is fed to it, and this data is processed via the layers of perceptrons, and this perceptrons consist of the informations, the knowledge, to produce the and combine together ultimately to produce the desired output. And those perceptrons are basically processed. The perceptrons, if you talk in terms of your human body, those perceptrons basically works in the form of a hidden layers. Now, one more example, very short example I will talk about. Like suppose there is a problem statement to classify whether the leaf is a diseased leaf, because leaf which is you are seeing on a tree, now you want to classify whether the leaf is a diseased one or a non-diseased one. So on a leaf there are certain patches. Maybe how you will classify, maybe the features are based on the certain patches. These are the patches which are basically talking about that these are the diseased leaves. So the patches which on the leaves are talking that these are having some diseases, and if there are no patches on the leaves, it is talking about that it is a non-diseased leaves. Now how you will classify? So if you quantify the same leaf, you will give the position of the patches, because the features, based on the features of the leaves, including the patches, you will give it to the system. So you will give all those features of the leaves. What are the features of the color, the patches, the pigmentation of the leaf. So these are given as the input based on the weights, and some weights are assigned for each input. How much weight you are giving for a color, how much weight you are giving to, suppose x1 is the color, x2 is the pigmentation, how much the shape of the leaf, the pigmentation of the leaf, the how much weight you are giving to the patches which are there on the leaf, so and many other features of a leaf. So you're giving all those weights, and ultimately and adding some biasness. If you have given a leaf, the shape of a leaf, so how much biasness you are adding to it, or how much weight, how much biasness you have given when you are giving the color of the leaf, when you're defining a color of the leaf. So added with some biasness, you are defining whether the leaf belong to a class A and leaf belong to a class B, where the class A talks about the diseased leaf and a class B belongs to a non-diseased leaf. So basically this is how the ANN actually, the model which we have talked in the analogy, the model actually is built in. So ultimately, if you see in terms of the equation, so it is x1 multiplied by some weights. X1 was in the previous analogy, we have talked about P1. So P1 the feature, so x1 is a feature, w1 is a weight, x2 is a feature, w2 is a weight, and so on. And there can be n number of features, so x3, x4 to xi, and all those features are multiplied by some weights added together, and with some biasness added together, and ultimately they give you the function of, so you get a summation function of xi into wi, and the I which goes from 1 to n. So let's come to now the basic concepts of ANN. So it is the basic terminology which we have defined. So it is a model which is an assemble of interconnected nodes and weighted links, which I've already explained it to you. So all these interconnected nodes, the input nodes are there, and all the nodes are has assigned with some weights, and ultimately these based on the weights and some threshold value, some biasness factor or the threshold value, the output is determined. So output is, so Y is basically the function of X multiplied by some weights with some bias, with some threshold value. So this is how the model is actually is built on. So output node sums up each of its input value according to the weights of its links, and it compares the output nodes against some threshold T. Now we need to also understand what type of connectivity can also be there in the neural network, because we are talking in terms of the network which we are drawing in terms of input weights and the biasness. So we also need to know also what types of network connectivity can be there. So there can be two types of network connectivity. One can be a feed forward network connectivity, or another can be a recurrent network connectivity. In the feed forward connectivity, the input there is a feed forward. Basically there is a single flow, there is a flow from the input to the hidden layer, and the data goes to the output unit. So so from the input unit taking the data from the hidden units, and then they transform into the output unit. So typically the first layer is the input and the last layer is the output unit, and it is basically the direction, the flow of the direction is unidirectional. Whereas a recurrent network, when we talk about the recurrent network, so this basically they belongs to some cycle. So these are directed cycles in their connection graph, and they are complicated. So they are more biologically realistic. Basically, when we talk about a recurrent network, because the output is connected with some of the inputs, maybe the output again will take some data from the input. So output can also, some set of outputs can also act as a same of some sets of input also. So output again serves as, maybe the output serves as some hidden layers in the form of some inputs. So that is what the recurrent network basically works in the form of a back propagation concept. And if you talk about feed forward network, so there can be a single layer feed forward network where there you have one input layer and one output layer, and there is no in between layers into it. So this is a single layer feed forward network, input layer projecting into an output layer. Then you can have a multi-layered feed-forward network where you have one or more hidden layers. So input projects only from the previous layer onto a layer. So input layer is passed to the hidden layer. Hidden layer will take the input data, can compute it, and then pass the data to the output layer. And ultimately, so this is a two-layer, where one hidden layer but fully connected network, and a feed forward because the data is unidirectional. it's in the one directional. You can have a multi-layered feed-forward network where you have a layer 1, layer 2, layer 3, because at various layers the data is transformed, and then ultimately it reaches to the output. This can be in your real life example also. Suppose this is a one very good example. Suppose teacher asking about whether the boy is intelligent, or before going to take an exam, just to get a hint whether the boy is an intelligent or a boy is not intelligent, or a class of students are intelligent or not intelligent, or in what particular scale they belongs to. So because the teacher directly do not knows each and every student, so and or the principal, because directly do not, suppose the principal wants to know, so principal directly do not knows the student, so it will ask to all the subject teacher. Maybe the subject teachers are not directly related to all the students in a best way, so they can talk to all of the class teachers, and then the class teachers can directly interact with the students, or based on some vibe or based on some results, and they can give whether this person is intelligent or other person is not intelligent. So in this case, in this example, I talked about where the data has moved from. So this is suppose the student features is taken by the class teacher or the class teacher. Then it goes to the various other subject teachers who have also taught, but they were not with the class teacher, so those information also added by the subject teacher, and ultimately the data goes to the principal whether the person is intelligent, on a principal prediction based on these layers. So this example basically talks about input layer, the hidden layers, layer 1, layer 2. So input is the features of the student's grade, and again asking verbally, or again taking other tools from other teachers, and getting the output of determining whether the student is intelligent or not intelligent in the form of, and this is basically your output layer. So this is a multi-layered feed forward network. So it can be a single layer, it can be a multi-layer, or it can be a two-layer. So again depends what type of prediction you want to go, and what type of data you have. So if you see in the recurrent network, which I talked in the previous PPT, so in a recurrent network, a network with the feedback where some of its input are connected to some of its output. So in the recurrent means your output again serves as some form of input. So if some of the output is again taken back, given basically a feed back propagation algorithm basically works. So here the input is given to the output serves again as an input to learn more by every time, so that the accuracy can also be increases. That key number of times, maybe one time the output is not right. So if the output is not right, so again I will check it again, this output will go as a feedback mechanism, and based on the feedback mechanism again I will measure what the output I am getting it. So this type of network is known as a recurrent network. Now the third part, which has been asked to me to talk on it, talk on various applications of ANN in management. So I'll talk about the various applications, the various research aspects of ANN in management, and then we'll talk about the one very beautiful example applying on those analogy, what we have to understand, the various topologies, what we have understand so far, and the application in terms of management, how we actually implement it. Because if you're a student of a social science or a management science, so how, in what way you are going to collect the data, or in what way you are going to apply the same data to understand your to mark your, to get your results, to get your output. So in that case you need to understand the ANN concept in management perspective. So so basically when you talk about management perspective, so the ANN is applicable in marketing, in healthcare, in any healthcare management, in speech recognition, in face recognition, even in various other aspects of the firm, marketing, finance, in your strategic management, business policy, in your manufacturing. So these tools are basically applicable. Let's talk one first in the terms of marketing, because if you talk in terms of management, so management consists of various other various areas like marketing, finance, HR, strategic management, manufacturing. So let's talk one by one, and where it has a prevalent use. Normally the research, you as a researcher, or you basically takes if you're a management students, you go into a marketing side or you go into finance side, but in all the side, this is a tool, or this is the model, or this is a concept, a machine algorithm which can be applied on any of the management application, any of the functional areas of the management, be it marketing, be it HR, be it finance, be it OB, be it strategic management, be it operations, so be it IT is also one of the integral part of the management. So any fields or any branch of management, you can apply the ANN. So ANN can be applied to many marketing decision problems which could previously be tackled only by the multivariate. Like earlier, if you might be knowing, because if you're attending this FDP, so you might be knowing the research concept. So if you also have studied the research methodology, the multivariate statistical analysis, the various tools like the discriminant analysis, the conjoint analysis, and many other the multiple regression model, so which are basically the example of multivariate statistical analysis. So it is not like earlier you were only sticks to the multivariate statistical analysis, but now the ANN can actually be applied for many marketing decisions other than the multivariate statistical analysis. So and when we talk about ANN, so it's very beautiful tool in market segmentation. So typical like market segmentation, which particular segment what is the market segment, which particular segment a particular market belongs to, whether segmentation can be done in form of in many forms. It can be the segmentation can be done in form of gender, the segmentation can be done in the form based on the product, based on the regions like northwest, east, south, because suppose if we geographically, if you want to segment your market, so if we take an example of India, so in India also you have so many you have four or five or six reasons, and everywhere that people have a different culture, different caste, different creed, they have a different taste. So in marketing, if a firm has to sell their product, so how which particular feature is liked by which particular region, so very beautifully a firm can do this analysis using an ANN. So based on the features and the market segmentation can very well be done, which particular market the particular product should be launched or should be targeted. So it is a very beautiful tool for market response modeling. Your consumer spending patterns, very important, like based on the consumer, because suppose in urban areas as compared to the rural areas, the spending patterns are there is always a difference in the spending patterns is as compared to the urban areas vis-a-vis the rural areas, or a metropolitan vis-a-vis a normal city, a non-metropolitan city. So in that case also the ANN can be applied to new product analysis, to if you're launching a new product, so which particular area, which particular segment this particular product will be based on, where we need to target. So that analysis, a new product analysis in any form, you can do with the help of ANN. Because I'll be talking about a live example of how to, the application part of it also, and then the customer characteristics, basically what is the liking or what is the disliking of a customer, so that can also be identified, because you are classifying, ultimately you're classifying, and given the features you can very well classify using your ANN concept. So target marketing, to which particular class to target, whether the which particular niche, how you can target, whether to target to adult or whether to target to young or whether to target to the child class. So ANN can be very well used in the target marketing. So these are the most crucial point for research activities in the field of marketing. But only thing is that there are a number of times there is and nowadays, because the lack of application on the is the lack of application on the individual level data. But if these are the typical problems, but if you have a data, and these are the very good research areas where you can apply the ANN. So and these kinds of problems are encountered in the context of purchase behavior, like in the tradition of stochastic model of consumer behavior. Stochastic model basically means where you are applying some random variables, some random models to take the decisions. Stochastic models are basically the decision making models based on some random variables. So to analyze the consumer behavior, rather than going to with the stochastic model based on the random variables, you can very well analyze based on the various features, various accurate features, and you can analyze the entire concept of your marketing in using your ANN theory. So research areas in marketing by use of ANN, like research areas or the applications. I'm not talking only the research areas, but the applications. So broader sense, it can be applied to forecasting, market development forecasting, sales forecasting, price elasticity modeling. So sales forecasting. So this will be the output, and based on the what are the parameters you need for forecasting your sales, whether, so you can take those as an input and in the ANN, because in the analogy I explained you how the data goes and how actually it computes the output. So you can talk about the customer satisfaction assessment, whether the customer is satisfied or a customer is a dissatisfied customer, or a class. So this can be very well measured on using the ANN concept. The customer loyalty, because this is a very important concept now for any firm, whether the customer is a loyal customer, because based on the reward points, based on the spending patterns, based on the how many times the customer turn up in the organization, so that basically counts the loyalty and retention of a customer. So whether the customer is a loyal or whether the customer is retained or not, again that can be very well measured using the concept of ANN. So the features, one can provide the features, that the features can be like, suppose if I take this example, the feature can be whether the what is the, how many times the customer is turning up, how many days in a month the customer is coming for the shopping in that particular store, what is the spending of that particular customer of on a product, or what type of product the customer is purchasing, or whether the customer is just coming or going as a window shopping. Or so based on those features, you can very well analyze whether the customer is a loyal and the customer will retain to the organization or not. So then market segmentation, I already explained. Customer behavior analysis, brand analysis, very important. Market basket analysis. Market basket analysis means which particular product, bundle of product will be sold along with a product. Like for example, normally the bread is sold along with a milk, or an egg is sold along with the bread. So normally in the morning hours, you go to purchase milk, you will see some of the products which are sold along with the milk are bread, butter, eggs, and all those other dairy products, which are normally kept at the outside counter by the shopkeepers. Because this is a concept of market basket analysis, the association. Market basket analysis basically stands for association of one product to the another product. So ANN can be very well applied to the market basket analysis, even in the departmental store, how the products have been placed. Because a customer will, what is the possibility whether the person will purchase a brush, if he'll purchase a toothpaste, will also purchase a brush or and other items related to it. So so in that case, how the departmental store are going to place their products so that it is convenient for the customer, and it is a likelihood, the chance of likelihood to get the other bundle of other products also sold along with that product. So that basically comes under your market basket analysis. So in that case, ANN is very beautiful tool to analyze whether to combine this market basket analysis with your ANN framework. So for storage layout, for customer gender analysis, for this example I've already talked in terms of analogy, in terms of gaming and shopping experience. Then market orientation and performance, market strategy, strategic planning and performance, market data mining, to name a few. So customer consumer choice prediction, this is a very upcoming area, discrete choice analysis, where we talk about whether customer, like there can be various, like for a particular even a single product has many variants along with. Suppose if you go to buy a refrigerator, it has so many variants, but so which particular variant, even a particular brand, there are a number of variants. So which particular variant the customer will choose based on the pricing, based on the features, and which particular feature, what is the price being charged by an add-on feature. So all those comes under the consumer choice prediction, very hot topic in terms of marketing. So this can be again be implemented using an ANN. Then market share forecasting is so these are the various areas and the broader areas, and almost covered each and every aspects of the marketing, which can be applicable in terms of which can be worked upon, or which can be where the data can be analyzed by applying the artificial neural network. let's talk about in the field of finance. So and basically in the field of finance, ANN are frequently used in modeling, and in finance it is more of forecasting, time series forecasting, stock market forecasting. So it is in many, so in forecasting problems, because in finance you basically deal with many of the forecasting, and time series is one of the example. So and in recent times, time series analysis has increased. So and ANN actually provide a better fit, particularly in financial time series. So this is very important. So in the time series analysis, and with so many non-linear dynamic relationship, you have a time series with a linear relationships, and where you have a non-linear dynamic relationships, there also you can apply ANN, the artificial neural network. I'm talking about, it is usually difficult to interpret the meaning of the parameters in the neural network, because neural networks are seen as a black box. Because if I come back to this, because when we talk about, if I come back to this, so this is basically when you're assigning some weight, some threshold value, they are basically the black box. What all weights or what all threshold you're assigning, they basically are treated as a black box. So when we talk about a time series model, right? So in a time series, so if we talk about in the time series model, so many of the parameters will seen as a black box. So it will be, to some extent, it will be very difficult to interpret the meaning of what has been taken for a non-linear dynamic relationship. So to construct for the pattern recognition, or what will be the pattern, what will be, how the stock market will go, or what pattern, because in the stock market normally you study the pattern of a stock market key in the past, how it was moving, and in the future how it will be move on. So accordingly the investment decisions can be taken upon. So the prediction about the investment decision, or what will be the stock prices of the next few days, or whether the stock will go high, or whether the stock is going to crash, or whether the market is going to crash. So that can be analyzed using the ANN concept. So the topics of in finance are forecast of changes in the value of financial assets under the forms of stocks, currencies, analysis of strength of historical financial statements can be done in, these are the essential topics in finance. And they can be basically used by ANN. So if we talk in terms of recent examples, so Chase, Manhattan Bank, Pete, Marwick, American Express are between the most companies that efficiently apply neural network to solve problems in finance and portfolio management. Nowadays, in finance and portfolio management, these network theory and the concept of ANN, because network theory, you might have heard the concept of network theory, basically a concept of artificial neural network, because it is again a network based concept. So these are very well applied in these researches. Foreign exchange rates, stock values, credit risk, business failures are widely estimated by the neural network models. So these are the broad areas where the research areas of finance and accounting by use of ANN: financial health prediction, compensation assessment, bankruptcy classification, analytical review process, credit scoring, signature verification, risk assessment, forecasting, stock trend classification, bond rating, interest rate structure analysis, mutual fund selection, compensation assessment, credit evaluation can be done in using the ANN. So next is application in the field of manufacturing. So in manufacturing, again, you forecast what will be your sales, what will be how much products you have to produce. So and what will be your production cost, what will be your delivery dates. So these are the forecasting, basically quality control, optimization. So these are the forecasting related applications which are available, which are applicable in the manufacturing and production side. So as the quality control problems correspond to classification, so thus the appropriateness of the application of ANN is supposed to be as good as those in the fields of finance and marketing. So wherever you have the classification issue, there all you can apply ANN, and it gives a better result, because since the time is less, and I'm not talking about the machine learning, but there are n number of algorithms which you study for the classification. Like you have a naive-based classifier, you have you study the decision tree theory, you study the random forest concept, you study the artificial neural network. So these are various other models which comes under the classification concept. But and if you compare these models on a particular data set, you will find it because in many of the cases it has been found that artificial neural network always gives a better accurate results as compared to the other classification model, like which I have mentioned right now, like naive Bayes classifier or decision tree classifier or KNN classifier or other or random forest classifier and so on. So in manufacturing, you can use it in engineering design, quality control, storage design, inventory control, supply chain management, demand forecasting, monitoring and diagnosis, process selection, all these areas where you have a data with respect to the classification, and you can apply your ANN concept over here. In the field of strategic management and business policy, so ANN is a very efficient tool for determining and clarifying the relationship between the strategic planning and the performance and assessing decision making. How much whether the strategies which you have actually made has actually impacted the business firms, or whether they have boosted up the business or whether they have slowed down the business. So that classification also comes. So you can take the input parameters as those all those planning which you have done, and based on those planning and the performance, you can assess your performance and the decision making as an output, and you can very well apply your ANN over here to analyze the plans, the policies, and how they have actually impacted the decision making process. So current examples of, just wait a minute. Yes. So I just need to check whether my battery is not slowed down. Yes, it's charging. So if you talk about the current examples nowadays, other than in terms of the areas, in terms of the business, so in banking, because we talked about right now in terms of the functional areas, now if we talk about the various other business applications, so in banking, in nowadays, which is where ANN is being applied, so it is being applied in credit card attrition, credit and loan application, fraud and risk evaluation, and loan delinquencies. Many firms are basically if I say about credit card attrition, so whether based on the usage of the card patterns, based on the usage of the card, whether the person will be continuing with the card, or whether the person will continuing with not with the credit card, or other than that, whether based on the uses of the card, you can very well define whether the person who has used the card is right now is a fraud transaction has happened, or a gender normal transaction has happened. So you can classify data into a fraud category or data into a non-fraud category. So risk assessment, fraud assessment, credit and loan application evaluation. Credit and loan application evaluations, I can talk about that, whether the person will take a loan or whether the person will not take a loan, based on the features like income of a person, the spending pattern of a person, the background of a person, what business, which particular business the person is. So suppose these are some of the feature, and accordingly I can classify whether the person will take a loan or whether the person will not take a loan. So if a loan application has come, and whether the loan is, or you can classify whether the loan will get approved, whether the person loan will get approved, or whether the person loan will not get approved, based on these features. What is the income level? So in a bank, when a person gets applied to a loan, and based on what is the income level, because whenever you apply for a loan, you fill certain documents where you show that what is your income level, what is your gender, which business you are into it, whether you are in service, whether you are a business, how much your assets you owned it, whether you hold a credit card or not, whether you have a saving account or not, what all banks you have a saving account. So based on those features, bank basically evaluate whether to give a loan, whether not to give a loan, or whether the loan is passed or whether the loan is not passed. So this can again be, because the features can be taken as P1, P2, P3, P4. so many features can be taken based on the weights, whether you will, how much weights you are going to give to the income level of a person, how much weights you are going to give to the business the person belongs to. So accordingly you can assign the weights plus the biasness ki, like whether how, while assigning the weights how much bias I was, so adding some biasness, subtracting some biasness to it, or adding some biasness to it, you can actually evaluate whether to give a loan to a person or whether not to give a loan to a person. So this kind of analysis can be done in banking. So in business analytics, customer behavior modeling, customer like market research. In the market research problems, you can have customer segmentation, fraud propensity, market research, marketing mix, market structure, and many of the firms are actually using these concepts. Of all, many of the market research firms are using the ANN as a very important model, as a machine learning algorithm to analyze these concepts. In defense, it is very much useful in counterterrorism, in facial recognition, in feature extraction, in noise suppression, in object discrimination, sensor, sonar, signal identification. Very, very important tool as an ANN, because accuracy and because the accuracy and the n number of features and the model has an advantage of taking n number of features, passing through various other hidden layers. You can give n number of information to the hidden layers to actually analyze the true accuracy, the true output of based on the inputs. In education industry, it is basically used in terms of adaptive learning softwares like dynamic forecasting, education system analysis, student performance modeling, personality profiling, and adapting learning software like right now in because everything is online. Even in many of the you encounter so many of chatbots where based on your interaction they learn what exactly you want it or what exactly you're looking forward it. So in fact in Google, when you type some wrong words, automatically it corrects this because based on the adaptive learning. So this is how the feature actually works. In finance, corporate bond rating, corporate financial analysis. So in financial industry, credit line use analysis, currency price prediction, loan advising, mortgage screening, real estate appraisal, portfolio trading. All these are the applications. Medical, very important. In cancer cell analysis, whether the cancer is a benign or a malignant. So this is because you are defining a cancer as into two classes, whether the cancer is dangerous or not dangerous, that is a benign or malignant. So that analysis is again done using an ANN, ECG and EEG analysis, emergency room test advisement, expense reduction, quality improvement for hospital systems, and many other areas. Securities in analysis like market analysis on stock trading advisory systems. They basically use whether to invest in a particular stock or not, whether to invest in which particular stock. So this is where ANN is used. Transportation like routing system, truck brake diagnosis systems, vehicle scheduling, all these areas. So it covers broadly each and every areas of the business where the ANN can be applied and basically is being applied nowadays. And I talked about the various functional areas, the research aspects also, where you can apply ANN and you can use it with the respect to certain these industries in which particular area, functional area. Suppose you want to do your research in the area of stock market, and so you can very well in the stock market, so you can very well use the concept of ANN in portfolio trading analysis, in your stock trading advisory systems, how it impacts, how the model is actually impactful in your in giving the stock trading advisory system. So you can combine n number of combine these features with these business applications in your research aspect. So now the last part of my presentation, where I'll be talking about the application of the ANN with respect to the analogy from the starting of the PPT where I've talked about, and the application which I've talked about. Now implementation of taking the problem statement and how it is being applied. So let's take one example of customer loan approval. So now understand what is the problem statement. So because you as a research, because an FTP is normally meant for research scholars, for the faculty. So let's understand what is the problem statement over here. So suppose you have taken a problem statement like many stores are now offering their customers the possibility of applying for for a loan directly at the store so that they can proceed with the purchase of relatively expensive items without having to put up the entire capital all at once. Because even initially the offering of the consumer loans was found only in connection with the expensive purchases such as cars, but it is now if you see in Amazon and Flipkart, where you go for shopping, even for a small items you can have an EMI options available. But earlier you were having an EMI options into expensive purchases like cars, washing machines, televisions, etc. But nowadays, even in a small item, even a item of 1,000 rupees bucks or a 2,000 rupees bucks or a 4,000 rupees bucks, there also you get an EMI options. So the loan, so people can apply at a loan directly at the store even for purchasing the relatively less expensive item. So the loan applications are filled out at the store and the consumer deals only with the store clerks for the entire process. Now what happens, the store however relies on the financial company because the store is connected, because the loan approval of a loan is basically dependent on the financial company. The store however relies on the financial company, often a bank, that handles such loans, evaluates the application, provides the funds, and handles the credit recovery process when a client fails to fulfill the repayment schedule. Because a financial company will evaluate whether to provide even a loan for a small purchases, or whether the how much the funds to be provided, what can be the credit recovery process if the loan being not paid, if the client fails to fulfill the repayment schedule. So for this study, so suppose for an example here, we can take that 1,000 records of consumer loan applications that were granted by the bank together with the indication. So you have collected 1,000 records, consumer loan. So 1,000 people suppose applied for a loan. So you collected the records and that were granted by, so together with the indication whether each loan had been always paid on schedule or there had been any problem. So what you did, so you provided the data did not, so the provided data did not make a more detailed distinction about the kind of problem encountered by those bad loans, which could range from a single, because whether the loan has been converted into a bad loan or whether the loan has been, whether there is a no defaulter in the loan, so which could range from a single payment that arrived late to a complete defaulting on the loan. So let's now talk about the loan ANN application to a loan approval. Now how it actually works. So we use an ANN to classify the consumer loans and identify potentially risk loans, that is loans that might not be repaid on the schedule. So you have taken the classified consumer loans and then you need to identify what are the potential risks associated with it. Potential risk means whether it was a paid on time, whether it was not paid on time. So here 15 input variables were taken. So your P1, P2, P3 or X and Y, you can keep it those P1, P2, P3 into various X's. So 15 variables, so each application has 15 variables. Those were your input variables that included the number of members of the household with an income, the amount of the loan requested, whether or not the applicant had a phone in his house, and many other things, whether the house, in which particular business or whether the person is doing a job or a business, whether the person is holding a credit card or not. So these are the different types of variables. To name a few, these are the various types of variables which were taken as an input, which were there in the application form. So, and you can now understand that some of these variables are numerical and some of can be categorical, because if you talk about whether the person application had a phone in his or her house, so yes and no, so it is a categorical variable. What is the income level, which is a continuous variable, what is the income level, basically it's a continuous variable, so which you can actually measure it. So some of these variables were numerical, which you can measure it, and some of the variables which were discrete, which you cannot measure it. So example, the number of relatives, while other use as a digit as a label to indicate a specific class. Example, the value 0, 1, 2, 3 of a variable, or 8 refer to 4 different classes of employment, like 0, 1, 2, 3, like whether you are into job. So these are like where you cannot measure it, only you categorize it. 0 stands for you are into a job, 1 stands for you are into a business, 2 stands for you are into a private job, or 3 stands for you're into public job, and so on. So this is how the variables being measured. So now let's take an example. Suppose these are the 15 variables. So the number of relatives was one of the variable, input variable. Another variables were the relatives with job, number of relatives with job, telephone number, how many telephone connections you have, whether you have a telephone number or not, whether you have a real estate or not, whether you have a residence seniority, other loans, whether you have taken other loans or not, or you have payment methods, what is a job type you do, what is a job seniority, net monthly, what is a net monthly earning, whether you have a collateral or not, what is a loan type which you have applied it, whether you have applied for a home loan, whether you have applied for a car loan, so what, or whether you have applied for a personal loan, or again in personal loan also there are a number of categories assigned to it. So what is the amount of loan, what is the amount of installment, and what is the duration of a loan. So you have so from so suppose number of relatives you have from 1 to total components, it is numbers, it will become into numbers. Number of relatives with job, it can be again 0 to the total component. Telephone number 0 or 1, where 0 stands for no and 1 stands for yes. Real estate, whether you own a real estate or not, so 0 stands for no and 1 stands for yes. Residency seniority from 0 to date of a loan request. It's like whether how much days has been passed from the day the loan has been requested. So other loans, whether the person is having a other type of loan, house loan, other categories of loans, so again it's a categorical variable. What is the payment method, whether whether the person, what is the payment method. So 0 and 1, suppose there are two payment method, by cash or by banking transaction. Or what is a job type of a person, maybe 0 stands for a business, 1 stands for private job, 2 stands for public job, 3 stands for a self firm. Then what is the job seniority, like 0 to the date of loan request. Again, net monthly earning, it can be any value, what is the monthly income, so it is again a continuous variable. Collateral, whether you have a collateral, so how many types of collaterals you have, how many loan types you are having. So loan types, you can have 0, 1, 2, 3, home loan, car loan, savings, personal loan, and so on. Amount of loan, amount of installments, and duration of loan will be the integer value, which is again a continuous variable. So you computed and your output is variable is that what is the repayment probability, whether the person will, and which stands from suppose 0 to 100. So what is the repayment, what is the probability whether the person will pay the loan on time or whether the person will not pay the loan on time. So basically whether you want to understand that whether the loan will, what is the probability whether the loan will not get converted into a bad loan. So the desired output variable is the desired output. So real just give me 1 minute. Am I connected now? I am audible.
Yes, ma'am, you are.
Thank you. So so your computed output variable, so your desired output variable is, so 0, so because so you have to classify it. So 0 means if repayment irregular or null, and 100 means if repayment on schedule. So if anything value which is less than 0 or anything value which is greater than 0 means the repayment on schedule, or you can make it as 0 or 100. So again, what we have done it in the analogy which I have talked about. That's the reason I explained you the analogy behind it. So for each record, a single output variable indicated whether the loan reach was extinguished without any problem, that is Z is equals to 100, or with some problem, that is Z is equals to 0. So you have defined two classes, Z as 100 or Z as 0. In the analogy where we have, in the previous example, an analogy where we have assigned 0 as female and 1 as male. So you can assign any classification. So here we assign Z if 100 and if Z is 0. So it means that 100 means on time loan payment and 0 means defaulter. So again, we talk about the topology, because that's the reason I talked about the second case, the concept of neural network. So whether in which particular topology we are going to work. So whether we are going to apply a multi-layer or a single layer or a topology. So so here suppose we applied a multi-layer perceptron with one input layer and one hidden layer and one output layer. So this is a two-layer ANN. You can apply a multi-layer. So to more than one layer comes basically under the multi-layer perceptron. So you are applying one input layer, one hidden layer, and one output layer. So we use a network with 10 nodes in a hidden layer. So 10 nodes hidden layer means, and so for, and here you can use any algorithm, machine learning algorithm. So for here in this example, the reactive taboo search and a meta heuristic has been used to train the ANN rather than the back propagation algorithm. Yes, I have not talked about, because these are the various types of algorithm which are basically used, whether you want to go for a feed forward mechanism, whether you want to go for a back propagation algorithm. Back propagation algorithm means it's a kind of a recurrent network, which I have already explained it to you. The output will serve, some of the outputs will serve as an inputs, again serve as an input, or they will work as a feed forward feedback mechanism to analyze again to increase more accuracy of the input. So in its posterior analysis, that is the bank classified loans with z is equals to 0 as bad, and bad loans in the provided data. So if you see, so and only about 6% of the loans were classified as bad. So when you do the analysis, so what you got it that the 6% of the loans were classified as the bad loans. So when you talk about the output now, the output which we got it from here, so the single output of our network turned out to be in the range from -30 to +30, 130, whereas the corresponding real output was limited to the value z is equals to 0 and z is equals to 100. A negative value of the output would indicate a very bad loan, and thus negative values were clamped to 0. So again, that's the reason even in the neural network, the function is basically converted into a sigmoid function. Sigmoid function means whatever the value, suppose you take it as 0 to 50, or anything which is value which is less than 0 will be classed as 0, or any value which is greater than 100, or which is greater than any other value will be classed as 100. So a negative value of the output would indicate a very bad loan, and thus negative values were clamped to 0. Similarly, outputs above value 100 were assigned the value of 100. So this is how you convert into a sigmoid function also. So a 30% tolerance was used on the output. 30% tolerance means basically you take some chances of error also. What can be the chances of error? So those chances of error, or what can be, are basically taken as a tolerance value. So what is a significant value you are taking? So suppose here 30% tolerance was used on the output, so that loan would be classified as good if the ANN computed a value above 70, and the bad is their output was less than 30. So हमने 0 और 100 के बीच में एक टॉलरेंस भी लगा दिया. एक हमने टॉलरेंस मतलब टी फैक्टर, द बायसनेस फैक्टर एक लगा दिया, जो हमने बी वैल्यू जो हिडन लेयर्स के अंदर छुपा हुआ था, कि अगर मेरा लोन 70 से वैल्यू से अबव, एक तो हमने 100 से अबव वाले को 100 ही डाला, और 0 से लेस देन वाले को 0 ही डाला, और एक टॉलरेंस हमने एक और थ्रेशोल्ड, टॉलरेंस का मतलब एक थ्रेशोल्ड लगा दिया हमने कि 70 से अगर अबव की वैल्यू होगी तो वो 100 ही काउंट होगी, और अगर 30 से लेस की वैल्यू होगी तो वो मेरी 0 काउंट होगी, वो मेरी 0 के अंदर ही काउंट होगी. बाद में की 30 और 70 के जो इंटरमीडिएट बैंड के अंदर आएगी, दैट इज द लोन्स दैट फेल इनटू द इंटरमीडिएट बैंड, दैट इज 30 to 70 were left as unclassified. So maybe they will not be classified. So the rationale for existence of the unclassified band is to provide an alarm requesting a more. So it means that there are more data to be required to analyze whether the loan will convert it into a bad loan, or the loan will convert it into a good loan. So this is how the data is being set to understand the output variable. So here now coming to the previous cases, what we have we understood the feature of there we take as a concept of training set and the test set. So there were 1,000 cases, 15 input variables. So out of the 1,000 cases, 400 cases were used to train the model. So here 4:6 ratio was taken. It can be a vice versa also. So then the specific ANN was applied with the remaining 600 cases of testing set. So it can be vice versa. You can give 600 as a test set. So basically you as a user need to classify. Here basically who is analyzing the system. So as a user you need to classify how much data you are dividing into a training set, and how much data or how much records you are dividing into a test set. So this set so in that case you are dividing 400 cases as the training set and 600 cases as the testing set. So this set contained 38 cases that had been classified as bad. This is because the system knows it. The system already knows it. So out of the 600 test set, 38 were classified as bad and 562 cases had been repaid on schedule. This is already, the data has been already collected, and this you already know it. But now you are making a machine to that you are going to train the machine. So your output of an ANN for all the 600 cases were analyzed. And so if you see on this axis, so you have the output of the machine has been analyzed. So your repayment, what is the repayment probability? So 30 was taken. So this range, the green blue area is taken as an unclassified area. Anything beyond this, below this area, is taken as a bad loan area. Anything above this area is taken as a good loan area. So your good, and these are your dots are your record sets, which has come as an ANN outputs, and which are categorized on your axis. So all these records, these points, these records where my mouse is, these records are has come into in your bad loan area segment, and these are the manius records which are there at the good loan area, and these are your unclassified area. Okay, so there are and there are certain crosses which are wrong classification of. So these are the crosses. These crosses over here basically signifies that they were actually a bad loan but classified as a good loan, and there are no crosses here. So there are only 3 cases were there in this example. There were 3 cases were there where they were good loan, but they were bad loan, but they were risky loan. They were bad loans, but they were classified as the good loan. They were classified in the good loan area. So these are the sampling errors. These are your errors which are counted as. So this will basically determine this based on this, your accuracy of the model will be determined, how much the model has given the accurate prediction. So when we talk about the experiment result, so clearly an ANN separates the given cases into the two non-overlapping bands, the good ones near the top and the bad ones near the bottom. So no loan was left unclassified. So in this case, there would have been no cases required additional intervention. So here, if you see in this diagram, there were no unclassified loans, but there were 3 by mistake classification of the test cases. Those were 3 cases which were classified as good loans, whereas in reality, they turned out to be the bad loan. So a posterior inspection of the values of their input variables did not reveal any obvious symptoms that were problem cases. So, and now coming to the last concept. So what would have likely happened is that the application did not repay the loan as scheduled due to some completely unforeseen and unpredictable circumstances. So, so this is also supported. So maybe these 3 cases can be, it is all because maybe the COVID, the applicant was a person who was basically into a habit of paying the loan, but maybe there is a possibility, like you can take an example of a COVID, that unforeseen pandemic has come, and because of that there is a death of a person, or the person has lost his business, or the person has lost his job, and because of that the person has not paid the loan on the scheduled time. So so these 3 cases, so this is also, so these 3 cases can be supported by those facts also. So this is also supported by the fact that the bank officers themselves approved these 3 loans. Thus one must presume that they did not look too risky at the application time, but at the time of repayment they become risky. So it is again the reason, maybe they were the good loans, but they're actually become a bad loan, but it can be many of the reason also, or this can be maybe the correct classification was not done by the bank people. So the ANN, however, so here in this example, what we understand that the ANN, however, was more discriminate than the bank officers, since the ANN would have bank officers basically classified, but ANN would have denied 35 loan applicants that scored less than 30, as it turned out that all these 35 loans had problems with their repayment, and thus the bank would have been well advised to heed the network classification and to deny those 35 applications. So this is how the system is going to answer about is going to work when you're applying the model. So this I talked about the real life example. Now the last part is that the neural network as a classifier. So we should also know what are the weakness and what are the strengths before applying this particular model. Am I audible?
Yes, ma'am.
Thank you.
Yes, ma'am, you are.
Yes, thank you. So let's talk about some of the weakness. And then we'll talk about the strength. Because neural network, because it's a network, you have so many layers inside it, and the more the layers you are going to add on it, so the more complex the system is, the more complex the algorithm becomes. So it takes a lot. And there is so that is the reason it takes a long training time to train the system. It requires a number of parameters, typically best determined empirically, the network topology or the structure, like whether which particular topology you are going to work, whether you are going to work on the recurrent network topology, or you are going to work on the feed forward mechanism, or you're going to work on, even in the feed forward, you are going to work on the two layer or a multi-layered perceptron model. So again, it is typically determined by the number of parameters, and a number of times it has a poor interpretability, because there is a difficult to interpret the symbolic meaning behind the learned weights and of the hidden units in the network, because the weights which you're assigning is basically, number of times it's very difficult ki the weights which you're assigning is right, or the weights you're assigning is wrong, or the accuracy of the weights which has been given to each and every inputs or each and every parameters is correctly defined or not. Now, but though there are certain weaknesses, but this can be, with a thorough investigation and with the thorough concept, this can be always overcome. But the model has lots of strength behind it. So it has a height, because in the cases where you have a too much of noisy data where the data values are very scattered, where you have a very different unknowing patterns in the data, so that is known as a noisy data. So when you have too much of noisy data, so ANN has a very high tolerance to noisy data. So in that case, these models are very good models to best fit your data. It has an ability to classify even in untrained patterns, the patterns which are not even untrained, that has an ability. The ANN has an ability. It is well suited for a continuous valued inputs and output. Continuous, which is your, like, income is a continuous value, like the number of people, this is a continuous value, age of a person, a continuous value, height of a person, continuous value. So it is well suited for a continuous valued inputs and outputs. And that is the why, because it is more of a regression type of the model basically takes in, the model is basically more built on the regression concept. So it is well suited for the continuous value inputs and outputs. But again, it classify it but taking into a sigmoid function, it basically classify your variables, classify the same continuous value into a classification variable. Then it is successful on a wide array of real world data. Algorithms are inherently parallel, and techniques have recently been developed for the extraction of rules from the trained neural networks. And nowadays, various applications like your facial recognition, your speech recognition device, various chatbots, your Alexa, your Google Maps, they all are using this your artificial neural network. So n number of applications are basically based on this particular network. So this is all from my side. Now the house is open for question and answers. I hope I have.
Yes.
Okay, there is a question that is ANN similar to the logistic regression? No, no, no. In regression, you study logistic regression is also one of the classifier, because when you study linear regression, logistic regression, so logistic regression is a classifier. ANN is also one of the classifiers. So both have different algorithms into it. Logistic regression takes into consideration the sigmoid function, but ANN at the output side, when you are classifying it, then only it converts. Otherwise, the entire data is computed on the continuous variable, on the continuous data set. So logistic is one aspect of classification, is one algorithm, one model of machine learning, which comes under the supervised learning algorithm, whereas ANN is another aspect of is again a classic one set of algorithm, which is a part of your supervised machine learning algorithm. But yes, both, if similarity wise, both are supervised learning, both are the supervised machine learning algorithm, and that too with the classification problem. Any other question? Let me see the chat.
Mohammed Asim, you have raised your hand. Do you have any question?
I don't think so.
So I hope I was able to justify the ANN, because I was told that ki number of times ANN being taught from the computer science perspective, but I have to teach from the management perspective. So I hope I am able to justify with a very simple analogy how the basically the concept works, and then to apply with the management applications in various functional areas of the management, as well as the various business areas, how it can be applied to.
Yes, ma'am, very much. So shall we conclude the session, sir? Okay, no, ma'am, there is one more question from Hirendra Soni,
Which tools are used for ANN? I don't know whether you in what reference you are talking about, but basically ANN works, the model, it works in the form of an activation function, which takes a set of inputs, and then taking some weights and the biasness factor, even and basically it works in the form of a layer, just as a human biological neurons, like where you have the certain information which is already there as a trained information, and the information which actually passes through the ANN. So but the only thing is that tools, basically when you apply that the concept, you have to apply whether you're going to work on the recurrent concept, or whether you have to apply it on the feed forward concept, so or whether you have to apply in various topologies. So tools are basically in the form of a topology. Okay, so topologies, which particular topology you want to run the model. Okay, and another question was there, what are the softwares where to run the ANN? So you have various softwares. You have R, you have a Python, which are very supportive tools for running which have a very beautiful and a very supportive packages and the libraries, built-in packages and the libraries for running your ANN. You have a MATLAB, then you have then you have many other softwares, because normally I work on R and Python to implement the ANN. So these are the very robust tools for implementing your ANN concept. I think even in advanced version of SPSS, I have seen somewhere like ANN being applied, but the R and Python are the very robust tool for, and these are open source softwares. So these are very robust tools for applying ANN. And the libraries are, these are all open software, so you will get all those libraries free of cost on the on the website, even the software is free of cost. I think no more other questions.
Doctor?
Thank you very much, ma'am. You have given us an effective and instrumental insight of artificial neural network with respect from a management perspective to everyone, with easy and practical examples in almost like marketing, finance, and every aspect, from linking present to the future, from base to so participants, today is Friday, hence we will be starting our next session immediately at 11 o'clock. So please stay connected. Now I request the organizers to send the feedback link in the chat box, please. Please
Thanks a lot.
Yeah. Please note that a feedback link will be open for next 10 minutes only. Please fill the feedback form.
Thanks, Prajakta.
Yes, sir.
There is one more question.
Yes, sir.
There are some questions.
Yes, okay.
Is it possible to apply this to study the mode shift behavior of commuters if a new boat route is introduced? In what aspect you are asking, Sabita? Yes, we can apply in behavioral finance to study the investor psychology very well, because you need to understand what are the features which actually define the investor psychology. So identify all those features, and then then you categorize your investor psychology. Identify the features which basically talks about the investor psychology. So investor psychology means the stock market, how much the trading they can, one of the features they can do like what all trading how much frequent trading they can do, what is the how much investments they are doing it, how much frequent traders they are, and whether they are the whether they work on the bull market, whether they work on the bear market. So these are some of the features. You can take all those features which defines the investor psychology, and then you can classify the investor psychology into various classes, and you can very well apply this particular model to understand the investor psychology. Sabita question, I was not able to understand the question of Sabita. Is it possible to apply
I
this?
think she's asking about the logistic decision, and if it is logistic decision, then obviously it is being applied.
Yes, if it is a logistics, so classification, it's a classification algorithm. So very well you can apply.
Hello.
Normally,
Actually,
see
ma'am,
what you do, you convert, even if you have a categorical variable, you convert your categorical variable into a quantifiable terms, and then basically you pass on these variables as pass on these features as an input, and to categorize it, or you take to analyze your output. But it is very well works in the, even if you run in R or Python, you need to quantify even your categorical variable, you need to quantify it, then only you can run the model, and ultimately ANN very well works in the quantifiable data. It really very well works in the quantifiable data.
Savita, do you have question?
Mohammed, somebody has raised his hand.
Mohammed Asim by mistake has raised his hand. Savita, do you want to ask? I think that, ma'am, you actually said the right thing, which maybe she was asking. If Savita, you have a question, please ask.
actually, ma'am, it was related to the mode shift behavior of introduction of a new board route. Actually, there is an existing board route is already working there, and bus routes and other passenger routes are already there, and this new AC boards are introduced there. So we have to study the mode shift behavior of people. The cost of travel will be more for the new route. So we want to know if they will shift or not.
Yes, very well. See, very well you can apply ANN in this by takes all those inputs which are going to talk about the shift of the boat route, or so very well you can apply the ANN over here. You need, that's the reason I started with an analogy, how you actually work. That's the reason I talked in terms of access, in terms of features, one by one, step by step. Otherwise I would have started just with a normal computer science concept. The reason was that how you can apply each and every concept. That I started with the two features. I talked about you can take n number of features. So only thing is that what are the features? See, important is that what is the output you want to analyze. So what output you want to analyze, so you categorize your output, and based on, and those to study those output, what are the features you have to take, and based on the features you have to train the system first of all, and then accordingly you have to test the system. So you can very well apply these models to categorize your data. So first you train the system, and then you categorize your data, whether the shift is required or whether the shift is not required. So first you train the machine, what are the situations or what are the circumstances when the shift is required. So train the machine with all those features, with all those circumstances where the shift is required, and then then later on, once the machine will be trained, and then check the accuracy of the machine with the test set. And once you confirm that your accuracy is very well defined, and you can tolerate this type of accuracy, taking a significant error, taking a significant deviation of the error. So ultimately later on you can use this particular system, how much in what all accuracy you can find out whether the boat route has to be shifted or not. So anything can be done. It depends what you want to understand. So define the feature to understand that particular concept. That is altogether is basic behind this ANN.
Ma'am, there is one question of Bireshwar Pradhan saying that can ANN be applied in food category?
Yes, depends. It can be applied in any category. Now see what, now tell me what type of question you want to, whether a person, what type of, in a food category, to analyze, to understand the customer behavior, whether the person in a person has a choice of a lavish, in a urban city, a person has a choice of a lavish restaurant, or person likes a do not want to go with a high joint food joints, or high category food joints, or in a food category, like what type of food taste, based on the, like a person is a non-vegetarian or a vegetarian person, so whether a person has a taste of whether the person is most likely that the person is a vegetarian or a person is a non-vegetarian. So based on the eating habits, based on the eating patterns of a person, you can very well classify a person, whether in a food category a person is a vegetarian or non-vegetarian, or a liking of a person in a vegetarian or non-vegetarian. Even a food, based on the feature of a food, like in the leaf example, very well I quoted a leaf example, a leaf classified into a diseased leaf or a non-diseased leaf. So a food classified as a stale food or a non-stale food, or a food classified into a royal food or a non-royal food, or many other classifications. So what all, again, depends what all research you want to do in the food category. So there can be a number of examples which can come into this.
I think that's all for the day, ma'am. Thank you very much. Thank you very much for solving our queries and all the doubts, ma'am. Thank you. It was indeed a great session. Thank you, Priya, ma'am.
Thank you. Thank you
Thank
so
you,
much for
ma'am.
inviting me.
Thanks a lot, ma'am, for coming and giving us such a beautiful session, because we was a little bit skeptical, because you have a very tight schedule. We all know. So, ma'am has managed this. It's a wonder thing she has done. So whole night we was
Yes,
like waiting for the ma'am's things.
sorry,
Thanks a lot,
I
ma'am.
really, I have again a UGC HRDC session just
Yes,
after this.
you
So
told me.
I was, so thank you
Thank
so much. And I hope I was able to fulfill the, what actually was required for this FDP. I was able to fulfill those aspects of the FDP.
Sure.
So thank you so much once again. Thank you.
So, thank you, ma'am. For our second session of the day, we start at 11 a.m., which is on IKS Knowledge and Fit India Movement. Resource person for the session 2 for the day will be Mr. C.A. Sunil Gupta. Now I, Prajakta Bhoite, on behalf of Department of Management, SMBS, School of Management and Business Studies, Jamia Hamdard, in collaboration with AICTE ATAL, announce the first session of today's FDP is concluded successfully. Thank you very much. See you all at 11 a.m. And don't forget to fill up feedback form. Thanks once again. Take care. Have a good day and stay connected. Thank you, sir.
Okay. Thank you, Prajakta. So Sunilji, are you there? I think that Sunil, Dr. Sunil Gupta has joined. Sunilji, have you joined? Wait for 2 minutes only. We'll start.